300. And we are talking in more detail about things that are found in the geosphere. Most of you have completed that worksheet, and if I haven't handed it back to you yet, most of you completed the worksheet from yesterday. If I did not give it back to you yet, it's up here for me to pass back out to you. Virtual friends, you should have feedback on yours if you turned it in. But I will say that one of the questions was like, which one of these items, check all that apply, are part of the geosphere? And it had, and this mixed up several of you, grass and trees. Why are, and I know why some of you thought grass and trees, because they grow on the ground, and the ground is the geosphere.
But they're alive.
But they're alive. So what sphere are they actually a part of, Fiona? Biosphere. Okay, so be careful. If it's something that's actually a living thing, it's the biosphere. That tripped up a handful of you, and you guys marked grass and trees. I understand that because they're on the ground. They come out of the ground, and the ground is the geosphere, but the trees and the grass themselves are not geosphere. Now, mountains, canyons, those were on the list. Those are part of the geosphere because they are part of the land. They are landforms, okay? Right. Because, yes, like we talked about, the tectonic plates moving cause the mountains, cause the canyons, depending on which way the plates collide.
Right now.
Are those cups with you?
There are jars sitting over here, and they are for tomorrow. Yes. And then let me real quick go over this. Virtual friends, did you see that I sent a message on Seesaw, I think yesterday, or maybe even the day before, saying that we're going to do an experiment tomorrow and have access to a, it can be a glass jar like this if your mom does any candy or anything like that. Or if you just have like a regular drinking glass, that would work too. It just needs to be made out of glass for the experiment to work. A plastic cup won't work. So that being said, that's tomorrow. You're also going to need like a really thin string, like a piece of thread or fishing line or something like that. I would not say dental floss because a lot of times those have like a minty or cinnamon coating on it, and that coating might mess up the experiment. But if you have dental floss that's just plain floss without any coating on it, then that would work too. And then you need a paper clip. Those are the main things that you need, and then you're going to need water, but I know everybody has water at their house. Like you've got a faucet.
Yeah, but I just got a new one because.
Okay, but for today, we're going to be talking about minerals and rocks, which are part of the geosphere. They are not alive, really.
Yeah, they're like formed.
They're formed by the geosphere. There you go. So we can actually flip past that first page that has the picture of the rocks and minerals, and it looks like a canyon or something on it. We could flip back that. I'm going to start reading, but then we're going to do how we did before, where I have volunteers and you may come up here and read so that they can hear you, or I may call on some of you guys virtual to read too. Okay, what are minerals? If you collect rocks, you might find a rock with red chunks or specks of yellow in it. The red chunks and specks of yellow are minerals. A mineral is a solid natural material made from non-living substances from the ground. Fiona, do I write that down? Is that your question? No? Or are you just raising your hand?
Mm-hmm.
Go for it.
My question is, I thought that a rock actually was the mineral. Is stuff in the rock mineral?
Stuff in the rock is the mineral. And if Kendall was here, she's going to watch this back. If Kendall was here, she had one of those like geode rock things that you can break open, and it has like the mineral crystal stuff. She was like just been waiting patiently because she wanted to do that in class for everybody. And I don't know if it's in her desk, but we won't do it without her. We'll wait till she comes back, or if she took it home with her. I don't know. But so Kendall, unless she got tired of waiting and already did it on her own at home, I'm not sure. But a mineral, it's a solid natural material, and it is formed inside of rocks from other non-living substances in the geosphere. Ezekiel.
So, like,
a couple of years ago, when my grandpa came over a lot, to watch me when my parents were doing things. So we used to so we have a rock bed by our sidewalk, and we used to look at those rocks and look at all the minerals in it, and he used to teach me about them. We found all types of like geodes, like we found quartz in them, and then like we rubbed them on the sidewalk, and some of them like made marks. And I noticed that, and I don't know if that has anything to do with the minerals. Because the rocks
It
that didn't have like very many minerals in it, didn't do it as much.
Yes, so it does. So different minerals have different properties, and so they do different things. So let me keep reading, and that's going to kind of maybe explain that a little bit. Minerals are made of elements. An element is a pure substance that cannot be broken down into a simpler substance. Such as gold. Gold is an element. So is aluminum, oxygen, hydrogen, and iron. Those things can't be broken down. They're not made of other things. They are the thing that makes things, other things, right? So I can take oxygen apart, like the air we breathe is actually like oxygen and nitrogen and some other things mixed together. Okay, there's little trace elements of other things. But if I were a scientist in a lab, I could break it apart into all of those different things. But when I get oxygen, I can't break oxygen down any further. Oxygen is a thing. It is a element. It is one of the basic things that is found here on Earth. Gold is one. Aluminum, oxygen, hydrogen, iron. There are lots of them. Lily, how many are on your chart at home? A lot. I want to say like 130, maybe even like up to 150 now, because the chart is actually still growing because they still find elements today. DJ, do you know how many elements there are?
No, I actually have something else I want to say.
Okay.
The hardness scale on the page 303.
We're going to get there. Don't get ahead of me yet.
No, I was going to say, okay, hardness is harder, but if like you made a pickaxe out of diamond, which is on the scale of hardness 1, it actually still breaks really easily because hardness is more used for putting it on, like sprinkled on like an iron pickaxe or that. Like that's why they coat drills with like the diamond on the tip. It's to stop it from heating up too much, and it helps it drill. Like you can't just make like a diamond, so that will break easily.
Right. Okay. We're going to talk about more about that chart when we get over to that page. Josie, yes, ma'am.
Okay, so I want to know, I have this like crystal thing, and I want to know, like, I know it's a little bit manufactured because there's like glue and stuff around it, but does that count as one of like the rocks that we're talking about right now, or is it like in different place during the geosphere?
It might be, yeah, it probably is some sort of mineral crystal type items, probably is. As we read more, we're going to read more about a couple of types of different minerals on the next page. So it might be. I have something that looks very close to what you just held up, Josie, and I got it when I went to the Pikes Peak mountain because it was like different crystals that they found as they were like climbing the mountains or whatever. They found bits of the minerals that had grown in the mountain as the mountain was formed.
Can I bring some tomorrow?
Okay, minerals are made of elements. Elements can't be broken down. Some minerals are made of a single element. Other minerals are made of 2 or more elements. Minerals are found in nature. For example, iron is found in the rock ore. Steel is a combination of iron and carbon. Because steel is made by people, it is not a mineral. So minerals are things that are made naturally in nature. Okay. All right. I want a volunteer to read properties of minerals. Zekel, are you raising your hand to read, or do you have a question?
Both. So I'm gonna read, yeah. So, and I just went outside and got a rock, and it has iron in it. Here, I'll show you. See that brown spot? That's iron.
Yeah. Oh, very cool. You guys see that? Yeah.
Yeah.
Awesome, bud. Where'd you get that at?
On my sidewalk. Yeah, they're all over the place. So, yeah. And so, where am I reading?
Properties of minerals.
Okay. The color of a mineral is the color of the surface of the mineral. Streak is the color of the powder left when the mineral is rubbed on a rough surface. The color of the
Pause.
mineral and
Get
its
that
streak
pause.
are
Pause.
often
Pause.
okay.
Pause. That's exactly what you were just talking about riding on the sidewalk, streak. Some of them have more ability to streak than others. I know when I was a kid, we would just grab random rocks and write on the pavement, and it would make like a white, almost look like chalk mark on it sometimes. But yeah, some of them work better than others. Okay, now continue. Sorry. There you go, rock chalk. Yep.
Okay,
All right,
what am I gonna where am I gonna start from?
the sentence after. Yeah.
Okay, the color of a mineral and its streak are often different. Can I keep reading?
Yep.
Luster is the way a mineral reflects light from the surface. There are two general kinds of luster. Minerals with a metallic luster look shiny, and minerals with a non-metallic luster look dull. Minerals with non-metallic luster may look waxy, pearly, earthy, oily, or silky.
All right, stop there. So if you look at the bottom of that page, there is a picture of pyrite, or more commonly known as fool's gold. It has a yellow color and it's a shiny metallic luster. So don't get confused with color and luster, because color means it has that yellowish color to it, and luster means that it's shiny. Okay. And if you write with it, it causes a greenish black streak that you see over to the side. And it's called fool's gold because it does have that yellowish and shiny appearance. So if you're mining and you're in a dark cave mining, originally people that found this mineral originally
Thought it was actual gold.
thought that it was gold. And then when they further inspected it, they realized it was pyrite, which is something different. But it got the nickname fool's gold because it tricked people originally that were doing mining back then. Okay, I need another volunteer. This time I'm going with somebody in the classroom. Shawnee Poo. Come on up, and I'll have you read Hardness. Okay, I got a book up here. You can read your book.
If you like how it said it reflects off the light, if you just stare at the rock outside, you kind of see little
like you can see little shiny specks.
Yeah.
Yeah. So there might be bits of a mineral in some of those rocks you see. All right, start with hardness.
Hardness is a measure of how well a mineral resists scratching. A hard mineral resists scratching better than a softer mineral. On Mohs Hardness scales, minerals are ranked from 1 inch. 1 pound?
Just one.
1. Which is the softest? Top 10 to 10. Which is the hardest? A mineral with a higher number will scratch a mineral with a lower number. By scratching an unknown mineral with materials that have no hardness, you can find the hardness of the unknown mineral.
Pause there. Thank you. All right. So on that hardness scale, Mohs hardness scale, if you look at that chart that's at the top, talc, which is number 1 as a mineral, it's more commonly like powder. Like, have you heard of talcum powder before?
No.
Because it's so soft, it's like powdery feeling. Okay. But all the way up to what DJ was pointing out, diamond. Now, a diamond can still be damaged, broken, scratched. You can still.
I thought diamond was the hardest it is the hardest, but it isn't the most resistant.
But it's the hardest, but it can still get damaged. Yes, for sure. Okay. Now, continuing to read. DJ, come on up.
it's also because diamond is very strong, but it's breakable because it is very easy to fracture.
There you go. And you're going to read all about that. Okay.
Miss Bab.
Yeah.
I'm at this point.
So, diamonds, like, they are the hardest material, and they usually, like, you know how, like, jewelry sometimes has diamonds in them? They have to cut them with lasers.
To get them the precise, like, I mean, you could just bang on it with like a sledgehammer and it would break, but it wouldn't be a pretty shape that I would want in a ring or a necklace or something. But yes, to get it to be cut in that very precise, pretty shape that reflects the light and looks pretty for jewelry, they do use lasers to cut it. Now, DJ is going to read more about properties of minerals.
Wait, did I take off the...
You can, it doesn't matter.
When a mineral is broken, the appearance of the surfaces of the mineral can help identify it. When their surfaces are smooth, the property that it has is cleavage. Cleavage is described by the number of planes along which the material breaks. Fracture is the property a mineral shows when it has uneven or rough surfaces. Go ahead. I finished.
Yeah, you're good. Thank you, DJ.
Okay.
All right. So did that make sense? When surfaces are smooth, the property that it has is cleavage. Cleavage is the number of places it could break at.
Yeah.
So if I were to just bang it with a little hammer or something, where is it likely to break apart at?
Wherever you bang it.
Well, some of them, depending on how it's shaped and depending on how it's structured, it may be more likely to break in a certain area than others. So I am like gross. I can't put my hands and do what I need. So for instance, if I were to hit the scissors like this, we know that they're very likely to split apart, right? Like that. But if I were to hit the scissors like this, is it likely to break in this direction? No. So the cleavage on where the fracture would be is where the cleavage is where right here. Like I can likely hit it apart here, but I cannot likely hit it apart here. Right. And so even though it may look like a solid piece of rock or mineral, there might be the way it's structured on the inside that we can't see, that like if I hit it from the top is this way, but if I hit it from the side, I'm not going to be able to do anything. Does that make sense? But you can't always see what the rock looks like from the inside when you're hitting it from the outside. Does that make sense? Okay. Oh my God. Okay. Zico.
Miss Bab, I'm gonna break this rock open. So can I do it later in front of the class to see what's inside it? I have
Yes,
a
you
hammer
may.
right here. Okay.
Of course you do. All right. Another reading volunteer for what are the shapes of a mineral on page 304. Jason, come on up. Wash my hands.
As minerals form, the elements they are made from form patterns. These patterns cause minerals to form geometric shapes called crystals. A crystal is a solid whose shape form a fixed pattern. Different minerals have different crystals shapes. Sometimes the larger structure of the mineral shows the same shape as the crystal structure. For example, if you look at the crystals of table salt with a hand lens, you will observe that the salt crystals look like tiny cubes. In other minerals, the crystal structure is much smaller and can be seen only with a microscope. Good job. We're gonna have to say this quiet when we're at the concert. Miss Cat will be back in a minute. She kept this. So I didn't play much at least because I was hoping to see her playing.
Okay, sorry, friends. Jason, did you read that whole page?
He read the left place.
On the left side?
Yeah.
Okay. All right, and then I will finish this off. Or not. Josie.
I'm not gonna read, but I have two things to show. So I'm looking at the different pictures, and this is an amethyst necklace I got for my birthday last year, and then this was my great grandma's ruby ring. It's real ruby.
Very
So
good.
those are just two crystals I wanted to show.
Okay. Perfect. That's awesome. Okay,
Miss
hang
Pat,
on.
my
Let me
birthday,
finish reading.
Opened the rack and I found a mineral.
Didn't you say that you were gonna do it?
All right, pause, Zeke. I'm gonna finish reading, and then we will look at your rock. Great.
I'll do
You wanna
another one in front of you guys.
read? Stop. Pay attention. You guys have a worksheet with this today.
I was gonna say because it says Mica right here. That reminds me of my mom's Mica powder that she uses on the cups. So
I'm sure it's the same stuff. Gray's mom, I don't know if you guys know this or not, she like designs and makes like water bottles and different and like all kinds of different stuff.
Grace's mom made me one.
Yeah, she makes a lot of different like water bottles and even pins and all kinds of fun stuff. But he said one of the things that she uses when she's making them is called mica powder, and I guarantee it's the same mica that we see in this picture down below. It's a type of a mineral, and it would be used probably to like give something like a hardness or a shine. That would make sense to me because it is a mineral.
Like powder that she puts on there to make the epoxy have color.
Okay, that makes sense. All right. I'm going to go ahead and read this last three little paragraphs on this side, and then we will look at Zeke, whatever he did. Some minerals, such as emeralds, the green one above, are also called gems. A gem is a mineral that is rare, beautiful, usually transparent. That doesn't mean clear, but it means see-through. And glitters or shines in light. In their natural form, gems are often rough and uneven. Gems can be cut into shapes to show their color and remove flaws. After they are cut and polished, gems may be used in jewelry. So that's exactly what Zeke, you were just talking about with like they use lasers to cut a diamond. So if you look in this picture above, the mineral on the left, the emerald on the left, you can see it doesn't look as shiny, and it's kind of just this crazy big green random shape. That doesn't look pretty like we would see in jewelry necessarily. But if you look over to the right-hand side of that picture, you see all of the emeralds that have been cut and polished so that they are the kind that you would see in jewelry. And then that has that transparent nature to it. Like, again, transparent doesn't necessarily mean clear. I think sometimes when you hear the word transparent, you think clear. But transparent actually just means see-through. So, like, I could hold up one of those little emerald stones, and it would be blurry, but I could see through it, right? Okay, minerals may be more useful in a purer form than the one in which they are naturally found. For example, copper ore contains other materials. The copper is separated from the other materials by processes that include grinding the ore to a powder, rinsing it with chemicals, and then heating it. At the end of these processes, the copper is 98 to 99% pure. For uses where a coating of copper is applied, such as copper coins, a penny, or copper utensils, this is pure enough. For other uses, such as wires and electronics, the copper may need to be purified even further.
Are we reading the next page?
No, we're going to stop there. Zekel, throw your camera on and hold up closely whatever you did And let me
Wait,
pin you
I'm
to the
gonna go
screen so
outside
we
and do
can see
another one. So you guys can see me doing it.
Okay.
Here,
All right,
I'll-
we've got you. Screen.
Okay. Yeah, I'm going outside right now.
Yeah, be on the
Miss
wall.
Dad, can you point your camera to?
There's iron in it right there.
Yes. Point my camera where?
Pointing to the class.
There's one that's kind of sparkly.
I have him pinned. Is it not showing on your screen?
Oh, it is. I was saying, put it to the class so I can see their reactions.
Oh.
This one looks like a
Thank you.
geode. I'm gonna break it open.
See? Oh, okay.
She likes using hammers.
Okay, I found quartz in it. See right there, there's quartz.
Hold it like still for a while because the camera's like going. Oh, it's hard to see.
Here, I'll go back inside and
It's trying to see it. All right.
I can
hey, right here, there's quartz, that little shiny part right there. Oops.
Yeah, we totally. Yeah, we see the really shiny parts.
Very cool.
Yeah, and then there's iron around it too. And this one has quartz in it too. So yeah, like all the rocks in my rock bed have minerals in it. So it's really cool, yeah.
Shawnee Poo. Awesome. All right. So next, what is going to happen is that you guys have a worksheet that goes with what we read today.
I was doing it while we were reading.
That was pretty smart. I forgot to hand it out to them, so they couldn't do it while we were reading. So, that's what I've got for today. Tomorrow, we're going to do an experimental with, like I said, you guys be prepared. Oh, I guess we don't have to stare at Zeke anymore.
I'm staring at him.
Be prepared tomorrow. Again, you need either a glass jar or a drinking glass. If you're here in my classroom, you know that I have
A whole bunch.
a whole bunch,
Plenty.
even though I don't have enough of the other supplies. So you're going to be doing it in like probably partners, not
I can bring
whole tables. You're like, just let me bring the stuff.
I can bring
We'll see. You're also going to need salt, quite a bit of salt maybe. Warm water, hot water, a spoon to stir, a pin,
I have one.
just a pin. Like I said, something thin like thread, fishing line,
I got that.
floss if it's not coated. The coated floss that has like mint or cinnamon flavor won't work. It'll mess it up. So if you have plain floss, that should work. And then a paper clip. It does not matter if the paper clip is big or small. However, if you have just a small drinking glass or a small jar you're using, you probably want a small paper clip. Okay. All right. That's what you'll need for tomorrow. I did put it in a message on Seesaw, so you guys should have that. That's what I've got for today, though. Any questions? Otherwise, you guys can go work on your worksheets. I'm going to hit stop record.